Okay, this video is on using the quadratic formula and the discriminant to solve quadratic equations and also tell us the number and type of solutions a quadratic equation will have. Quadratic formula is very powerful, can be used to solve any quadratic equation similar to using the completing the square method. However, it may not be the fastest method if you could simply take square roots to solve or factor a quadratic to solve. But this is kind of a neat formula to use. And it goes something like this. If you have a quadratic and a, b, and c are any real numbers where a is not 0, if you can put the quadratic in standard form, that looks like this, right? Ax squared plus bx plus c equals 0, the solutions to the equation can be found just by plugging in the following numbers where they belong. It's going to be negative b, or the opposite of b, plus or minus the square root of b squared minus 4 times a times c over twice the a value. We're going to use that in an example to solve this quadratic equation. In order to solve, you first make sure it's in standard form set equal to 0. So first, make sure you have ax squared plus bx plus c set equal to 0. So I need to actually add 8 to both sides if I'm going to do that. So this is going to become x squared minus 4x plus 8 equals to 0. Now that I have that, basically all you have to do is set up what a equals, b equals, and c equals and substitute into the formula. So I'm going to write it over here. My a value happens to be 1, my b value is negative 4, and my c value is positive 8. So if I'm going to plug it into the formula, it's going to be something like this. I have x equal to the opposite of the b value, which is negative 4, plus or minus the square root of the b value squared, that's negative 4 squared, minus 4 times the a value of 1 times the c value of 8. And that's all over twice the a value, which in this problem is 1. Now it's just a matter of simplifying. So third step is to simplify. By the way, this step right here is the toughest part of using this formula. It should be an easy formula to use, but it is sometimes challenging to simplify. So let's see how hard it is in this problem. I have minus 4 is really positive 4. Plus or minus the square root of negative 4 in parentheses squared is really positive 16. And then I have a negative 4 times 1 times 8. That's going to be minus 32. All of that is over 2 times 1. That's just 2. So let's simplify inside the radical. I have 4 plus or minus the square root of 16 minus 32 is negative 16. All of that is over 2. Notice how I have a negative inside of the radical. So what I'm going to do is I'm going to poke an I out. So I have 4 plus or minus I radical 16 over 2. Now this actually turns out to be not so bad because the square root of 16 is nice. It's just 4. So I have 4 plus or minus 4i over 2. Now this is a complex number. What I want to do is make sure to write it in standard form. So I have to divide both terms of the numerator by the denominator. So I'm going to really have 4 over 2 plus or minus 4i over 2. Now 4 over 2 is 2, and 4i over 2 is plus or minus 2i. And there are my solutions. They're imaginary, but nonetheless there are my solutions. So that's how the quadratic formula works. Let's go to the next slide. We can also use the quadratic formula, or part of it at least, to consider the number and types of a solution to a quadratic equation. So it's really important, once again, that the quadratic equation is in standard form. Everything's got to be in standard form. If you calculate b squared minus 4ac, and by the way, I don't think it's written anywhere, but if you have the quadratic formula, let's just rewrite it up here. It was negative b, okay, negative b plus or minus the square root of b squared minus 4ac, all of that over twice a. You'll notice this little calculation here, this b squared minus 4ac shows up right in here. Okay, let's see if I can go back. It shows up right inside the radical. So that tells us quite a bit about the number and types of solutions. Now, if what's inside of the radical is a positive number, you won't need to poke an eye out, will you? So it's not going to be imaginary, and if it's positive, you're going to have just two real number solutions. And if we had to make a just sketch of what's going on here, we would have a parabola that would have two solutions, and it would hit the x-axis twice. It wouldn't have to open down, of course, right? It could be a different quadratic that opens up. Let's just say we had another guy that went like that. We would have two solutions right there and there. So that's what's going on in this case. Let's go back to another example. If b squared minus 4ac is equal to 0, then think of it. What's inside of the radical here would be 0, and the square root of 0 just gives you 0. So there would be only one real solution to this particular problem, because plus or minus 0 is just 0. And it's kind of interesting. What's going to happen here visually, the quadratic only has one 0, so it would just touch the x-axis at one point that's tangent to the x-axis in math terms. It would just have one solution right there. It doesn't like dip down below and come back up and hit twice. It just hits once. Now, if b squared minus 4ac is less than 0, so that means what's inside of the square root would be a negative number, you'd basically have to poke an eye out, meaning you'd have two imaginary solutions. So we'd have two imaginary solutions. And if we had to graph that, this would be a parabola that just never hits the x-axis. Again, it didn't have to look like that. It could have been, one that goes like this, generally speaking, but it won't touch the x-axis. When that happens, the graph doesn't have any real solutions. It has imaginary solutions. So let's apply this. In this example, we're going to use the discriminant, which the discriminant value is that b squared minus 4ac, and let's go back to black. I'm not super fun right now. So the discriminant is b squared minus 4ac, and we're going to use that to give the number and types of solutions for each equation. For part A, I have x squared plus 2x minus 3, my a value 1, my b value 2, my c value negative 3. This is for part A, right? So I'm going to calculate the discriminant b squared minus 4ac for that problem. If I do, b squared is 2 squared minus 4 times the a value 2 times the c value negative 3. That's going to end up being, what, 4, and that's going to be plus, because the negative times negative is positive. 4 times 2 is 8, 8 times 3 is 24, it's 4 plus 24. I get positive 28. Now, because 28 is a number bigger than 0, if you go back to that last slide or look above, that means there's going to be two real solutions. Alright. If we look at part B, which is over here, a value 1 again, b value 2, c value 1, let's calculate it. If I do b squared, it's still 2 squared minus 4 times the a value times the c value. I'm going to end up with 4 minus 4. I get 0, and since 0 obviously equals 0, I'm going to have one real solution. And the last one, you might guess already what they're going to have this set up as. My a value is 1, my b value is 2, and my c value is 5. If I do b squared, it's 2 squared minus 4 times the a value times the c value, 5. That's going to be 4 minus 20. What is that, negative 16? Since that's less than 0, it's going to be two imaginary solutions. Can't spell here. Let's Just scratch out solutions. Now, one last example that I'd like to show you in this particular presentation is projectile motion problems. Another cool application of quadratics. We can use the equation h equals negative 16t squared plus v naught times t plus h naught. This gives the height h in feet of an object t seconds after it's been launched from an initial height of h naught with initial vertical velocity v naught in feet per second. So the key here is the h is your final height, t is your time in seconds, h naught just means your starting height, and v naught is your initial vertical velocity. Now, there's two cases for the vertical velocity. V naught is going to be positive if an object is launched upward. So if you think about, if you had a, let's say I just watched the Bears game today and Jay Cutler was on fire. They lit up the Tennessee Titans, and he threw a football, a couple touchdown passes to Brandon Marshall, and he threw the football initially with an upward arc. This would have a initial vertical velocity that is positive, greater than 0, since it's going upwards. If v naught is negative, the object's being launched downwards. So this might be, for instance, a volleyball player, right? Let's say this is ground. Volleyball player is up in the air, and this is a terrible drawing. That's supposed to be a net. I don't know how to draw a net, but let's say they hit the ball downwards, right? They spike it downwards. This would be an initial velocity that's less than 0, or negative. Let's see if we can use this to solve example 5. It says a diver jumps from a height of 40 feet above the water with an initial velocity of 4 feet per second. How long is the diver in the air? Well, let's see. We're going to use the formula that I have above, and let's see if we can figure out the initial vertical velocity. They tell us the initial velocity is 4 feet per second, so I know that is 4. And keep in mind, if this person is jumping off of a board, right, they're not jumping downwards through the board. They're going to have to jump upwards, at least initially, and then down they go, right, into the water. So it's going to be a positive initial vertical velocity. H naught is the initial height. Well, it tells us the board is 40 feet above the water, and so now we just have to find how long it's in the air. So that means we're counting from when he initially jumps or she jumps and hits the water, which means the final height, h, is 0. So this is how we're going to set up our formula. We're going to have 0 equals negative 16t squared plus v naught is 4 times t plus h naught is 40. Now, there's a few ways we can try to solve this. We can try to see if we can factor it. If we get lucky, we can try to see if we can complete the square, but let's just apply the quadratic formula here. What I'm going to do, actually, this is kind of neat. Let's do it since it's possible. Do you notice how all of these coefficients are divisible by 4? That would make life a lot easier as far as computations. Let's divide everything by 4 just to make life a lot easier. This would be 0 equals negative 4t squared plus just t now plus 10. Now my a value is negative 4, my b value is only 1, and my c value is just 10. So if I use the quadratic formula, it's not x equals, it's t equals in this problem. The time is going to be negative b plus or minus the square root of b squared, or 1 squared, minus 4 times the a value, negative 4, times the c value of 10, all of that over twice the a value, negative 4. Alright, let's see if we can simplify a little bit. So I have negative 1 plus or minus the square root of 1 squared is 1. Negative 4 times negative 4 is going to be a positive 16, and 16 times 10 is 160, right? So I'm going to have negative 1 plus or minus 1 plus 160, and then in the bottom I have a negative 8. This is negative 1 plus or minus the square root of 161 over negative 8. Now, I'm going to separate these and use my calculator to figure out the final answer. Let's think of the two answers here. I have negative 1 minus the square root of 161 over negative 8, or I can have negative 1 plus the square root of 161 and divide that by negative 8. Now, one of these answers is going to be positive and one's going to be negative. You might think that this second one is going to be the one that has a positive answer, but if you think about it, the square root of a 161, that number is bigger than negative 1, so the numerator will be positive, and when you divide a positive by a negative, this is going to be some negative number, which means a negative amount of time in the air. So that one I don't want to try. This one, however, is looking promising because I'll have a negative number in the top divided by a negative number in the bottom, and it looks like we'll be in business. So if I'm going to plug this into my calculator, unfortunately it erases all my strokes that I have, but I remembered the problem was negative 1, so I'm going to try to do this negative 1, and then I am going to do minus the square root of 161. Now I'm going to take that answer and I'm going to divide it by negative 8, and it looks like my answer is going to be about 1.71 seconds or 1.7 seconds in the air. If you had to type this all in at once, it's a little bit trickier, but you'd have to put everything in parentheses, at least for the numerator, right? So that the calculator would know that you're dividing that entire quantity by negative 8. Oops, not 8, negative 8. And we would get the same answer. So the diver would be in the air for 1.7 seconds approximately. Thanks for watching.